Okay, so actually I'll show you, I've got the Constructability Manager. So this one's, this example's got some more models in here. Again, it's a very simple building, but you can see how we're mixing and matching. So these little icons, this is an ArchiCAD model, these two are Revit, this is Revit, and this is ArchiCAD as well. Each model version we always keep in history, so we can always revert back to an older one if we wish. So we keep everything in here, and then we can view them and we can filter them and choose how we want to look at the models. So a typical work would be, once we've got the models in here, we want to know if it's constructible. So want to either to get the design fixed to make sure that everything is clash-free, but also if it's an early stage and there are some clashes in there or some things which definitely won't work, and we need to know that about that in the estimating, so we can make due allowance for them if it's going to be a big problem. Okay, so we create detection settings. I've got some set up here for columns and beams versus MEP. So we can just add the elements which we want to check against each other, and we create different analyses, different sets. So we just choose what we want to add, and then we run it, and then we get, just make this a little larger, we get a list of all the issues here. Just let me add a column. It tells us which type of elements there are that have been found to actually be clashing. So we can isolate these items, which, yeah, it's fine, I can see it, but it doesn't really tell you where it is relative to the rest of the building. So we've got some other views which we can use. We can auto reveal, and that will show it relative. And if we move the building and then we choose, it'll get rid of anything which is blocking your view, basically, so that you can see the elements that are affected. And we can also dim the model so it dims everything else. So you review all of these items, and then when you're happy that, yes, it is an actual clash, or maybe you're not happy about it, but when you're sure it's a clash, then we mark it as a constructability issue. And then it goes to this sheet, and here we can give it a description, add a severity, we can give it the owner, that's the architect, the engineer, status. So when we get new versions of the model, we can compare with previous and see, has this issue been fixed, which we reported last time. So that will be in here, and we can add comments and some references so the guys can find this okay. And we can also create report views. So show this, and then we can add these to the report, and then we send that out to the designers as an RFI. So once we've been through this process and we're happy with that, and we're ready to do estimating part, obviously it can be done in tandem as well. So I'll change this back to the cost planner workflow. Okay, and go to the takeoff. So here we've got a bit more of a list of the different takeoff items we have. We would go through, isolate these, investigate them, and see that it changes to a paintbrush. So if I wasn't happy that that was an RC slab, I could unpaint it, the number changes, and I could assign that to another takeoff item. This one is actually correct, so I'll just put that back on. You'll see that the number goes to 6. And if I open these up, I can check each of the quantities again. And if I take a look at column, so you see we have different types of quantities for the different elements. So we run different algorithms based on the type of element it is. Let's review. So we can paint these if any of them are missing, or if we want to take something out of the takeoff. So that's the normal process. You would run through and make sure you're happy with all these items, and then reassign as needed or add new items, and then we'll be ready to actually start planning the cost with that data. So these are all predefined. You can take your standard database and you can ask a pile cap to always look for this takeoff item, and if you set your models up accordingly, this will automatically link. Or we can do it manually. Like I showed before, if we go to the form editor, I can choose whichever. I can add a pile cap volume, and I could add that to a slab volume if I wanted. We can mix and match, and again we can use the built-in functions, the math, the logical, and standard, and come up with the quantities which we need. I'll show you this WBS bit in a little more detail as well when I've done the next stage. So basically the way we work this, it's an n-tiered structure. So we could start off just with an allowance for the substructure, an allowance for the shell, which may just be square foot based. Then we can start adding levels of data underneath and say, okay, I know we've got some piles, so I'll have a special foundation section. I know we've got a slab on grade, I know we're going to have some standard, and you could add an allowance there. And then if I just use the pile cap as an example, I could have a pile cap and I'm just going to deactivate assembly. So what this means is I've got a quantity there. I'm using the net volume of the pile cap, and I've just put an allowance in of 525.29 per cube. Okay, then so that's maybe an early phase, and you've got pile caps, maybe just schematic. And as the design develops, and I now find out its particular grade of concrete and its particular size of steel, I can add another level of data, more granularity, and then we've got these broken down into their pieces as well. And once we're happy that the scope of this part equals what we had allowed in that 525, we're happy that it's apples for apples, we then activate level of data. And you'll see here, this is the comparative unit. This is where we were before, the 525, and our unit cost now from the more granular level is 479. So we're getting immediate feedback here. We're getting a little blue down arrow saying that the price has gone down. These other areas where you can see in red, then they've gone up. So we're getting instant feedback there, albeit at a fairly simple level of where the price is moving with new designs. We can create different views in here to suit what we're actually doing at the time. So this is one. I used to be an animator myself, and I find this one incredibly useful, and something which was very, very difficult to do when I was in tender meetings, trying to describe where the prices exactly came from, and how much trust did I have in the takeoff. You can show that quite visually. So if I highlight the substructure, it highlights in the model, and if I highlight the shell, then that highlights in the model, and then I can take that to a more granular level, the standard foundations, and the special, which is the piles, and a slab on grade. So I'm getting instant feedback of where is my estimate come from, what is it actually using from the model. Then again, I'll pick on the pile cap. We can go down to a more granular level as well. If I select that in the takeoff, it will now show me, as well as highlighted in the model, it will show me exactly which estimating items are using that takeoff item. And if I want to be more granular, so maybe let's just isolate those, and I want to see what is using the edge surface area, and select that. It will show me the edge surface area in 3D, and it will also highlight do that again, sorry. It will highlight in the estimate and tell me that the erect and stripping formwork is using that edge surface area. Okay, so that visibility for an estimator, I think, is it's very, very useful. Just for that view, so we've already showed that we can see variances quite easily. We can see where the estimate is going. Then we can also explore different cost versions. So if I'm in here and just go to the cost plan menu, we've got save manage versions, and I can see the different versions of the cost plan which I have, and we can establish a set of target costs. So there may be the client's initial budget, it could be your own personal initial target, and we can establish those, and then we can compare any two cost versions. Okay, so we have a current version which is a circle, and then a previous version which is a square, and I can choose which ones I want to compare with each other, and then choose the target cost set. And then we have a traffic light system. So we've got green to show us, we've got a circle to show us the most current version, a square is the previous, and in this particular case we can change the range settings, but we're saying if it's green, it's between 85 and 100% of your budget, of your target. The square means it's at risk. Maybe 100, we've got 115% is too high. Maybe 101%, 102% is too high. But you can just manually define that, and that's how it will be shown in this tree. And then if we expand on that, it's the same estimating structure that we've used. We've got uniformat, so we've got substructure, shell, and just as an example here, that this building is actually within budget with this version. And the previous version, it was over budget, and we can trace that back and say, okay, it's the exterior enclosure that was causing the issues. And if I select that, because I've got this field selected here, it will actually filter out the cost plan items as well, which are affected. So again, for me, when I was in my tender meetings, why has the price changed so much? I could show someone very, very easily. Didn't have to get all my spreadsheets out. I could just show them straight away, filter it out. And then if you try and explain this to the design team about, trying to avoid value engineering, this is where the problem is with the design, Mr. Architect or Mr. Engineer, and you can show them in a very visual way using the same tool. So it will filter out this exterior enclosure or the superstructure. So it's very, very visual and easy to show to any of the project stakeholders.